Welcome back, everyone. We talked about the OSI. Now we're going to talk about the TCP/IP, so Transmission Control Protocol / Internet Protocol. Now, the fact that it says Internet Protocol, we already know that this is relevant for us because everything we do is through the internet. We've actually already talked about IP before when we talked about IP addresses, the Internet Protocol. We've talked about the V4 and the V6 if you remember. For us, we need to understand this TCP portion. What is this Transmission Control Protocol? So Transmission Control Protocol, it's connection-oriented, meaning that we're trying to essentially establish a connection between two different sources, and we want that data to be transmitted in both directions. So location A, or I guess device A, needs to be able to communicate with device B and device B to device A. We want to establish a connection between these two things, these two systems, computers, so that we can send data to each other over the internet. Now, the thing about TCP is that it has this built-in error checking and within the protocol itself. It's just designed to ensure that data does actually get transferred completely. It is the best protocol for the internet because on the internet, we want to make sure everything goes across. So we send data files, we send web pages, we send images, and we send it through the internet. We most likely almost always use TCP for that because the complete amount of data we want to send, we want to ensure that it is being sent. So let's walk through some of the rules of how this protocol of TCP works. So TCP operates when you think about it abstractly. Let's say you're trying to send message of some kind over to this other system from A to B. I'm going to use a metaphor actually here, where you can think about it as almost like delivering mail of some kind. And let's say this picture of this green envelope is the mail you're trying to send. Now, let's say what you do is you write down a message on this letter. What happens is that maybe this letter gets split up into chunks. It gets split into 4 chunks, for example, because let's say the letter is massive and for some reason we have to send it in pieces. Maybe we're sending a string of letters and you can't get the whole message unless you read them in order. What happens is that we need to send these from one source to the other. So here, imagine there are numerous paths. There are numerous ways we can get this message from one side to the other, or each of these individual parts from one side to the other. Each of these circles represents locations, and A and B represent locations on this map, for example. Now, IP, the Internet Protocol, as we mentioned, has to do with addresses. It has to do with knowing the location, the destination of where we're trying to send. So if we're trying to send our message from A to B, the IP address tells us actually the address of where we're trying to go. So we know where B is through IP. TCP has to do with ensuring that everything actually is getting sent to the final destination. So these pieces move through and maybe they take different paths in order to get there. Here, you can kind of see that these chunks are just taking whatever path to the final destination. But because we have the IP, we know what the final destination is going to be. But let's say one of our pieces gets lost and it goes to the wrong destination. TCP ensures that B gets all the pieces. If it doesn't, it has certain checks and balances inside of the protocol that will tell A, hey, I didn't get this piece. I need you to send it again. So you can kind of see this as some way for us to ensure that we're getting everything that we need. And then once it's together, TCP, this protocol, is also going to put it all together so that we can actually read the message. So that's kind of the purpose of what it's doing. This is a high-level overview of what the protocol dictates. Now, how this actually happens. TCP/IP, this framework, this mental model, is 4 layers now. So we talked about what it does, but here let's talk about the 4 layers, just like we talked about the OSI models in the layers. And remember, this is how computers connect to the internet and then transmit data between them. So we've simplified this, and we've kind of abstracted out these 4 layers in a very similar format. There's an application layer, a transport layer, an internet layer, and a network access layer. So here you can kind of see these layers mapping to the 7 layers. It's just that the application layer now represents the top 3 layers. The application layer, the presentation layer, and the session layer of the OSI model. Remember, application is the layer that dictates the protocol that the application needs. Presentation is what converts the actual data coming across into the format that the application requires and vice versa. Session layer is what maintains the actual communication session open so that all data gets properly transferred. So this is now represented in all together the application layer of the TCP IP model. The transport layer is still the same. The internet layer is the same. So again, application to internet, there is a translation that happens here. And there's also movement that happens here. Movement happens at the transport layer. The transformation happens at the internet layer. So this is where we convert what the application understands into the data format that the actual network understands. So that is happening at those two layers. And then the network access layer contains the data link layer and the physical layer, which, as we know, has to do with the actual physical device as well as communication between two devices on a network. So those are just being abstracted and contained together. Now, if this is still confusing, remember, this is logical abstractions. This is a logical model that explains how communication happens between two computers. It's just that with TCP IP, we're specific to the internet, whereas with OSI, it's any kind of communication between two systems. Now, where this gets relevant for us is when we think about TCP IP on the right-hand side, this logical model, again, captures some type of protocol. And that protocol that's relevant for us as web developers inside our actual system design, when we think about it, has to do with TCP and UDP. These are two actual protocols that exist in communication at that internet level. So this is what we're going to talk about in the next video. But before we move on, I do want to stress that you just need to understand how these layers are important, because as you read about system definitions and you read about different designs of systems, different networking communication problems that get solved, they're going to talk about at what layer some of these things exist. All you need to know is the definition of that layer, and automatically it will slowly start to make more sense. It's just something important for you to know and hold as some kind of principle in your mind of a framework that exists between communicating of two systems. So that's it. The actual more relevant practical information is going to exist in this TCP vs UDP lesson we're going to talk about next. So with that, I'll see you in the next lesson.